Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and try to solve it together. So although today's challenge is a really easy one, really easy to code, but there might be some confusions regarding how the method is actually working, why we are selecting 3 consecutive sides if you have already seen the solution. So let us discuss that clearly. So first of all, let us see the problem statement. We are given an array nums and you are allowed to select 3 elements and see whether it forms a triangle. Now out of all such possible 3 triplets selection which forms a triangle, you need to check whichever has the largest perimeter. Okay, you need to return that largest perimeter. So you can see that you can form a triangle with 2 1 2 and the largest perimeter is 1 plus 2 plus 2 is 5. Okay, so that's what, and you see in this array 1 2 1 10 you cannot form a triangle, you can never form a triangle because it won't satisfy the triangle inequality which says that the sum of two sides must be greater than the third side. Okay, so as you can understand by looking at this, the answer will be 0 if you cannot return any side, that is if you cannot form any triangle, just return the answer to be 0. And if you see the constraints, they are 1 if 1 to the 10 to the power 4, it means that you cannot even use n square, you have to use linear or n log n. Okay, so if you try to think a very brute force manner to solve this problem, the first thing which would come to your mind is that go through all possible triplets. So let's say for go through I and then again go through j. Okay, so j you can start from I plus 1 to n, and for k. So for all possible triplets of the triangle, you can just check for triangle inequality. Okay, you can just check for triangle inequality that if nums of I plus nums of j must be greater than nums of k, then nums of j plus nums of k must be greater than nums of I. In this way you can just check for triangle inequality. I hope that is very clear to you, that is not any doubt. Okay, and if you find they form a triangle, you can keep an answer max. Okay, and you can maximize that answer with the perimeter. Okay, the perimeter will be nothing but nums of I plus nums of j plus nums of k. So I hope this brute force method is very clear to you, and in order to optimize, you might think that what if, I mean, how can we eliminate 2 of these loops, because we need to solve in O of n, even O of n square solution won't do. Okay, so actually there is a very neat trick. Okay, so in order to solve these kinds of triangle problem, we have solved previously also in one of in our just last video. It is always convenient to sort the lengths. Okay, so you can sort the lengths. So if you see, if you have sorted it, it means that they are in the increasing order. Okay, so you will get some lengths which are in the increasing order, you will get an array. Okay, which are in the increasing order. So it means that the rightmost elements are always greater than or equal to the left elements. Okay, so now you see, if you are thinking something like this, that let's say this is an I, somewhere this is j, somewhere this is k. Let's say our answer lies here at these positions, our answer lies. What do I mean by answer? By answer I simply mean that the maximum perimeter which forms a triangle lies something like this. Okay, and this is the element is definitely nums of I. Okay, this is definitely nums of I, nums of j and nums of k. So you see, definitely you can tell me one thing, that this I will for now I will call nums of k as ak. Okay, the element at k. So you can definitely tell that this is holding true, right, because they are in sorted order. Now if you see, if ai plus aj, these are the two smaller sides, if they add up and become greater than ak, then that is sufficient to check for all the other 3 criteria, because you don't need to check now ai plus ak is greater than aj or not, because if this is holding true, then all other 3 criteria will only hold true for the triangle inequality. So this is only sufficient to check whether ai plus aj is greater than or not. Okay, now you see, you consider these elements. If you want the largest perimeter, you need to maximize this ai plus this aj plus this ak, right? You need to maximize all of them. So you see, one thing you can definitely say, that if there are some elements in between j and k, definitely let's say a k minus 1, definitely this k minus 1 is also greater than aj, is also greater than ai. Definitely this a k minus 2 is also greater than aj, is also greater than ai. I assume that there are at least two elements lying there, here, okay. So what can you say right now is that then if I replace this aj by this ak minus 1, and if I replace this ai with ak minus 2, I will also get something like this, okay. Now you see, definitely it is also true that if I find ak minus 1 plus ak minus 2 greater than ak, then definitely my also triangle inequality satisfies. But by doing this, what do you get? You get that k is the largest element here. If k is the side of a triangle forming the largest perimeter, you need the largest perimeter, right? So you, what do you select? You select the largest element, then you select the next largest element, then you select next to next one, okay. And you can easily understand that they will also form the triangle inequality, they will also satisfy the triangle inequality by checking this single criteria. So my statement, what I want to say is that, and you see the perimeter will also be greater. You can always say that this ij, ik, this will always be less than this ak, ak minus 1, ak minus 2. I hope you do understand, right? This statement is very important. So I hope you do get it. That's why you can say that if you are able to find some triplet in a sorted array, if you are able to find the largest triplet, they must be consecutive. They must be consecutive. That is what I am trying to say. If it is k, k minus 1, k minus 2. Okay. So if I want to write in statement, what did I conclude just now? What is my conclusion? My conclusion is nothing but if AK is the largest side of the selected triangle, largest side of the selected triangle means with the largest perimeter, it is obvious, then AK minus 1 and AK minus 2 must also be the sides of the triangle, must also be the sides of the triangle if they satisfy what do they satisfy? Triangle inequality. Now it is quite obvious that if AK minus 1 plus AK minus 2 greater than AK, this does not satisfy triangle inequality. If this does not hold true, then for any other AI and AJ greater than AK, this will not hold true. Then this implies this. Why you do understand? Because these are elements which were very close to K, K being the greatest value. These are the elements which were very close to K, but AI and AJ, they are even less than these elements. So if they can't add up to be greater than AK, then definitely smaller elements cannot add up to form AK. That is what the intuition of this problem. Okay, so that's what I am trying to say. So basically, any I will write another time that any triplet if you select and K is the largest element, then definitely this perimeter will always be less than equals to this K, K minus 2, K minus 1 plus AK, and this will always be your optimal value. Okay, this will always be your optimal value in selecting them. So I hope method is now at least very clear to you. So I will write this nums dot size and I will choose to sort this array. Okay, so nums dot begin, nums dot end, I have it, and I will iterate through the k element, right? So yeah, I will iterate through the k element. So I will start with int k, and definitely it will be n minus 1. I will start with n minus 1 and k must be greater than, I will say 1, okay, or greater than equals to 2. So and k minus minus, I will iterate from the left because that I am selecting the k value only, I, j, k among, and I and j must be k minus 1 and k minus 2. So what I need to check is that if this nums of k is less than nums of k minus 1 plus nums of k minus 2, then what you can do, you can simply return greedily, you can return. Why I am at in the first occurrence only, why I am returning, because k is the largest one and I am iterating from backwards, right? So it means that I am already iterating from the element which is the largest value. So if I first the first criteria which this will satisfy will be the greatest one, right? Will be the greatest perimeter one. Okay, so you can easily solve this now, I hope. So if you just add it, you will be and if you see, if you do not get after all the iteration, if you cannot form any triangle, you can just simply return 0. So that will be all. I will try to directly submit it and check if it works or not. You see it works really, but the runtime is really varied in this case. You cannot say that this is a very bad runtime complexity because you are using a simple n log n solution only using in sorting. In fact, I can prove this by showing you one thing. If you change this int to constant int, you see, if you try to submit it now, you will find a very funny thing. Okay, so now I was facing some network issue. If I just now try to submit, you saw that without this only integer, the runtime was not so great. But if you convert this to constant integer, you see you are getting 100% bits with zero runtime complexity, right? Zero runtime actually. So this constant int there is actually, if you tell the compiler that n is going to be constant, then it won't be necessary to replace this n every time whenever it is seeing in the code. It knows that in every occurrence it is the same and which is equal to the nums.size. So that's why the error somehow, the time complexity somehow this increases, but it should not cause actually that much difference. So yeah, I hope you do understand. It's very random for today because yeah, it is a small code actually, and it's not I mean not that difficult to implement. If even if you do something like, if you try to do a reverse sort, you will see that your time complexity even becomes really worse. Okay, you try that. So yeah, these small differences make this bits different for today. So yeah, that's all for this video. It was, I will say, easy but a little bit tricky to solve. So yeah, that's all for this video, and I will meet you in the next video. I hope your day goes as easy as the problem. Thank you so much.